Assalamu alaikum students. Once again, I welcome you all to my YouTube video class. This class is a continuation of previous session. In the previous session, we have seen chapter 2 number system. In that, we have seen the definition of data and how the data are represented in the computer and the types of number system, and also we have discussed about the conversion of decimal to binary. I hope you worked out and understood the previous class. So, how do you convert decimal to binary? Just divide the decimal number by 2 because the base value for binary is 2. So, just divide the decimal number by 2 till it get 1 or 0. All the remainder is your binary value. Then we have to write the answer from the bottom to top. Then convert decimal to octal. The base value for octal is 8, so divide the decimal number by 8. Then the next conversion is decimal to hexadecimal. Hexadecimal base value is 16, so divide the decimal number by 16. In today's session, we are going to learn about conversion of binary to decimal, binary to octal, binary to hexadecimal, and the conversion of fractional binary to decimal. Now let us see the conversion of binary to decimal. To convert binary to decimal, we can use positional notation method. What is positional notation method? Let us see now. This is the tabular column which represents positional notation and their corresponding weight. Binary to decimal conversion, so binary value is 2. So positional notations are 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, and it will be goes on. Then we have to write the equivalent weight of positional notation. 2 power 0, anything power 0 is 1. So 2 power 0 is 1. 2 to the power of 1 is 2. 2 square is 4. 2 cube is 8. 2 to the power of 4 is 16, 2 to the power of 5 is 32, and it will be goes on. This is the positional notation and their corresponding weight. So, to convert binary to decimal, we can use positional notation method, and also we have to follow 4 steps. Step 1, write down the binary digits and list the powers of 2 from right to left positional notation. Simultaneously, let us see the example sum. Then it will be easy for you to understand. Convert 111011 base 2 into its equivalent decimal number. So this is the binary digits. Because the base value of binary is 2, so the question is combinations of ones and zeros. Now we have to write down the numbers. 111011, and we have to follow the first step. Write down the binary digits and list the powers of 2 from right to left. So powers of 2 we have to use. Okay. So in the first digit from right we have to start right. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, and 2 power 5. Here we have written the positional notation for the given numbers. So, always the positional numbers start from 0. So, we have written 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, and 2 power 5. Now, we have to follow step 2. For each positional notation written for the digit, now write the equivalent weight. Here we have written given number and positional notation. Now, we are going to write the weight for each positional notation. What is the value of 2 power 0? 1. Anything power 0 is equal to 1. So 2 power 0 is 1. 2 power 1 is 2. 2 to the power of 2 is 2 to the 4. 2 into 2 into 2, that is 2 power 3 is 8. Then 2 to the power of 4 is 16. 2 to the power of 5 is 32. This is equivalent weight. Okay. So, we have written the given number, and also we have written the positional notation, and also we have written weight of the positional notation. Now we have to follow the third step. Multiply each digit with its corresponding weight. Now we have to multiply each digit with its corresponding weight. So 1 into 1 is 1, 1 into 2 is 2, 0 into 4 is 0, 1 into 8 is 8, 1 into 16 is 16 and 1 into 32 is 32. Now we have to follow fourth step. Add all the values. So we are going to add all the values now. That is 32 plus 16 plus 8 plus 0 plus 2 plus 1. Now the value is 59 base 10. The final result is 111011 base 2. This is binary value is equal to 59 base 10. This is decimal value. Our next type of conversion is binary to octal. Before going to this, we have to learn a tabular column. So this is a tabular column which represents octal numbers and their binary equivalent. The base value of octal is 8. So the values starts from 0 to 7. Okay. 2 to the power of 3 is 8. So this is 3-bit code. 2 to the power of 3. 3 we have to use 2 into 2 into 2 is 8. So 2 to the power of 3 is equal to 8. So we have to write equivalent binary values that is based on 3-bit codes. Okay. So this is 421 code. The name of the code is 421. So we have to write 4041. Then 2-bit means 2021 2021. Next 1 bit, so 0 1 0 1 0 1 0 1. Okay, so this is a octal numbers and their binary equivalent. The base value of octal is 8. So this is the combination of 0 to 7. We have to write equivalent binary values. Binary values is based on 2 to the power of 3 is 8. So 3-bit code we have to write. The name of the bit code is 421. So we have to write 4041. The next one is 2-bit code. So we have to write 2021. 2021. Next one is 1-bit code. So we have to write 0 1 0 1 0 1 0 1. 0 is off state and 1 is on state. Okay. Now we will come to the conversion. Now we are going to see binary to octal conversion. First, we have to group the given numbers into 3 bits from right hand side to left hand side. Okay. Here the given number is 11010110 base 2. This is the binary number. We have to convert this into octal numbers. Okay. So now the first step is group the given numbers into 3 bits from right to left. Now we have to start from right. 0 1 1. We have to make it as a group. This is first group. Then 0 1 0. This is second group and 1 1. We have only 2 numbers. So if there is 2 numbers, we have to make it as 3 numbers. Then we can add 0 to the left side. The leftmost groups have less than 3 bits. We can add 0 to its left to make a group of 3 bits. Okay. Now we have 2 numbers. If we have 1 number means we can add 2 zeros in the left hand sides to make a group of 3 bits. Okay. Now the second step is find octal equivalent of each group. So first group is 110. This is the tabular column you just see here. 110 equivalent octal number is, yes, that is 6. Next number is 010. That equivalent octal number is 2. Then 011 equivalent octal number is 3. So using this tabular column we can easily write the answer for this. Now what is the final answer? 3 2 6. We have to write base 8 because we have converted this to binary number to octal number. So we have to write 326 base 8. Okay. Our next type of conversion is binary to hexadecimal. Before going to this, we have to see the tabular column. The base value of hexadecimal is 16. So the number starts from 0 to 15. Okay, here we have to use 4-bit code because 2 to the power of 4 is equal to 16. That 4-bit code we have to use. Okay, octal 3-bit code we have used because 2 to the power of 3 is 8. So we have used 3-bit code for octal. This is 2 to the power of 4. So we have to use 4-bit code. So the name of the code is 8421. Whereas octal system we have used 421. Here we have to use 8421. 8 means we have to use 8081. Then 4-bit means 4041 4041. 2 means 2021 2021 2021 2021, and last 1 bit, so we have used 01 01 01 01 01 01 01 and 01. So this is the way you have to complete the table. Once again I will repeat how to write the table. First we have to write the hexadecimal numbers from 0 to 15. 0 to 9 are decimal numbers. So 10 to 15 we have to use alphabets. So 10 for A, 11 for B, 12 for C, 13 for D, 14 for E and 15 for F. Now we have to write the binary codes. This is 8421 bit codes. So we have to use 8 bits first. So 8 bits 8081. Next 4-bit codes, so 4041 4041. Next 2-bit codes 2021 2021 2021 and 2021. Next one is 1-bit code, so 01 01 01 01 01 01 01 0 and 1. So this is the way you have to complete the table. Now let us see the conversion. Binary to hexadecimal. First we have to group the given numbers into 4 bits from right to left. Here the given number is 1 1 1 1 0 1 0 1 1 0 base 2. This is the binary number. Now we are going to group the given binary number into 4 bits from right to left. The first group is 0 1 1 0. The second group is 1 1 0 1, and in the third group we have only 2 numbers, that is 1 and 1. So we have to make it as 4 digits. So what we have to do? We have to add 2 zeros in the left side. So if the leftmost group has less than 4 bits, we can add zeros to make a group of 4 bits. Okay. We have 2 methods to find the answer. First method is using tabular column. What is the value of 0 1 1 0? So the value of 0 1 1 0 is 6. So we have to take and write 6 here. Then what is the value of 1 1 0 1? Yes, the value is D. Next, what is the value of 0 0 1 1? The value is 3. So the answer is 3D6 base 16. Okay. This is the first method. Now we are going to do the second method. Now let us see the second method. As I said previously, the tabular column is based on 8421 coded method. So we have to write 8421 on the top of 4 digits. So 0110 we have to write on the top 8421. So we don't want to consider 0, we have to consider only 1. So the first 0, the value is 8, we don't want to consider, cut it. Then 1 for 4 and 1 for 2. Then again 0, we don't want to consider this, so you have to cut 1. Now we have only 2 numbers, that is 4 and 2. We have to add these 2 numbers. 4 plus 2 is 6. So the answer is 6. Okay. So the next group, second group, you just see that 1, the value is 8. 1, the value is 4. 0, 0 means we don't want to consider, so you have to cut the 2. Then 1, the value is 1. Now you have to add the values. 8 plus 4 plus 1, that is 13. The hexadecimal value of 13 is D. See the next group. 0 0 1 1 0 8 we don't want to consider, 0 4 don't want to consider, so we have to cut these 2 numbers. Then 1 2 1 1 we have to add only these numbers. 2 plus 1 is 3. So the final value is 3D6 base 16. So this is how you have to do binary to hexadecimal conversion. Now let us see the conversion of fractional binary to decimal equivalent. Already we have seen fractional decimal to binary, but this is fractional binary to decimal equivalent. Okay, so we have to follow some steps. The first step is convert integral part of binary to decimal equivalent using positional notation method. Simultaneously, let us see the example problem. Convert the given binary numbers, that is 11.011 base 2 into its decimal equivalent. Here we have two parts. The first part is integer part. The second part is after the dot. The second part is a fractional part. Okay. The first part, what we have discussed earlier, the same procedure we have to follow. We have to use positional notation method. Okay. In the positional notation method, we have to start from right to left. So the first part, integral part alone, we have to take and do the notational method. Okay, positional notation method. So you have to write 2 power 0, 2 power 1. So the given number is 1, 1 and the positional notation is 2 power 0 and 2 power 1. For each positional notation, now we are going to write the equivalent weight. 2 power 0 is 1 because anything power 0 is 1. So the weight is 1. 2 to the power of 1, 2 ones are 2. Now we are going to multiply each digit with its corresponding weight. So 1 into 1 is 1, 1 into 2 is 2. Now we are going to add all the values, that is 2 plus 1 is 3. Now the integral part is over. Now we have to move on to the fractional part, that is right hand side part. Now the fractional part is 0, 1, 1. For all the digits, write powers of 2 from left to right, starting from 2 power minus 1. Okay, so the difference is in the integral part, we have to write the positional notation from right to left, but in the fractional part, we have to write the positional notation from left to right. Okay, another difference is in the integral part, we will start from 2 power 0. In the right hand side, that is the fractional part, we have to write from 2 power minus 1. This is the main difference. Okay, so you have to write the positional notation from right to left, that is 2 power minus 1, 2 power minus 2, 2 power minus 3. Now let us see the tabular column, which represents positional notation and weight. 2 power minus 1, how we will write? 1 by 2, because minus is given, no, so we have to write 1 by 2. What is the value of 1 by 2? The equivalent weight is 0.5. We have to divide this number 1 by 2, the value is 0.5. In the same way, 2 power minus 2, how we will write? 1 by 2 square. 2 square is 4. 1 by 4. What is the value of 1 by 4? 0.25. Similarly, 2 power minus 3 will be written as 1 by 2 cube. 2 into 2 into 2 is 8. So 1 by 8. What is the value of 1 by 8? We have to divide. The answer is 0.125. And this will be goes on. Okay. So we have to remember these values. At least 1 to 4 values we have to memorize. Otherwise we have to divide that. Now we will write the equivalent weight. Okay. 2 to the power of minus 1, the weight is 0.5. 2 to the power of minus 2, the value is 0.25. 2 to the power of minus 3, the value is 0.125. Now multiply each digit with its corresponding weight. 0 into 0.5, value is 0. 1 into 0.25, the value is 0.25. 1 into 0.125, the value is 0.125. Now the next step is add all the values which you obtained. So now we are going to add all the three values, that is 0 plus 0.25 plus 0.125. Now the value is 375. Okay, the integral part value is 3 and the fractional part value is 375. So the fractional binary number 11.011 011 base 2 equivalent decimal value is 3.375 base 10. Base value we should write. Okay, so the final value is 3.375 base 10. Now let us see the conversion of octal to decimal, octal to binary, hexadecimal to decimal and hexadecimal to binary. Now let us see the first conversion type, that is octal to decimal. To convert octal to decimal, we can use positional notation method. So to convert any number system to decimal conversion, we have to use positional notation method. Just now we have seen binary to decimal conversion, right? In that also we have used positional notation method. In the same way, to convert decimal to any number system, we have to use repeated divisional method. Okay. To convert octal to decimal conversion, we have to follow 4 steps. The first step, write down the octal digits and list the powers of 8 from right to left positional notation. So this is octal number. Okay, so what is the octal base value? 8. So we have to use powers of 8 from right to left. Okay, whereas in the binary to decimal conversion, we used powers of 2, that is 2 power 0, 2 power, and we used no. So that is binary to decimal. Here this is octal to decimal. So we have to use powers of 8 from right to left positional notation. Balance 3 steps are same what we have followed in the binary to decimal conversion. That is second step. For each positional notation of the digit, write the equivalent weight. Third step, multiply each digit with its corresponding weight. And the fourth step, add all the values. Now let us see the example. Convert 1265 base 8 to equivalent decimal number. Based on the radix value, we can easily identify what type of number system. Here the radix value is 8, that is base value is 8, so we can easily say that this is octal number. Now we are going to write the given number, that is 1265. The next step is, now we have to write the positional notation, that is powers of 8 from right to left. 8 power 0, 8 power 1, 8 power 2 and 8 power 3. The next step is, for each positional notation of the digit, we have to write the equivalent weight. Okay, so what is the weight of 8 power 0? Anything power 0 is 1. So the weight is 1. Next one, 8 to the power of 1 is 8. 8 into 1 is 8. The next one, 8 square. 8 into 8. What is the value? 64. The next one is 8 cube, that is 8 into 8 into 8, that is 8 into 8 is 64, 64 into 8 is 512, that we have to write here. The next step, multiply each digit with its corresponding weight. So 1 into 5 is 5, 8 into 6 is 48, 64 into 2 is 128, then 512 into 1 is 512. And the next step, we have to add all the values, that is 512 plus 128 plus 48 plus 5. What is the value? 693 base 10. Okay, so the value of 1265 base 8, the decimal equivalent is 693 base 10. Now let us see octal to binary conversion. Already we have discussed binary to octal conversion, right? What we have done there? Just we have grouped the given binary numbers into 3 bits from right to left, and we have written the corresponding octal value using tabular column. Similarly, here for each octal digit, we have to write the equivalent 3 bits binary value using tabular column. Just look at the table. This is octal numbers and their binary equivalent values. Octal base value is 8, so it starts from 0 to 7. Look at the right hand side in the binary equivalent values, that is based on 3 bits. How we will get 3 bits? Octal means 8. So 2 to the power of 3 is 8, power 3. So we are using 3 bits here. The binary values are based on 421 code, that is 4 zeros, 4 1. And 2 bit means 2021, 2021. And 1 bit means 01, 01, 01 and 01. Now let's move on to the example sum. Convert 6213 base 8 to equivalent binary number. First, write the first digit, that is 6. What is the equivalent binary values of 6? Yes, that is 110. The next number is 2. What is the binary equivalent of 2? 0, 1, 0. What is the binary equivalent of 1? 0, 0, 1. And what is the binary equivalent of 3? That is 0, 1, 1. So, for each octal digit in the given number, we have written the 3 digits binary equivalent using this table. What is the answer of 6213 base 8? The answer is 110, 010, 001, 011 base 2. This is how we have to convert octal to binary conversion. Now let us see hexadecimal to decimal conversion. We have to follow same procedure here. As I told you earlier, to convert any number system to decimal, we have to use a positional notation. So, the conversion of binary to decimal, octal to decimal and hexadecimal to decimal, we have to follow the same procedure, that is using positional notation method. It will differs based on their corresponding base value, that is binary base value is 2, so we have to use 2 powers. Octal base value is 8, so we have to use 8 powers. Here the hexadecimal base value is 16, so we have to use 16 powers. So to convert hexadecimal to decimal, we can use positional notation method and we have to follow the 4 steps. First step, write down the hexadecimal digits and list the power of 16 from right to left, positional notation. Okay. The second step, for each positional notation written for the digit, now write the equivalent weight. The second step, we have to write the equivalent weight. The third step, multiply each digit with its corresponding weight. And the final step, add all the values to get one final value. Now let us see the example here. The example is to convert 25FB16 into its equivalent decimal number. The first step, we have to write the given numbers, that is 25F. Hexadecimal means 16. So 0 to 9 numbers are decimal numbers. 10 to 15 will be considered as A, B, C, D, E and F. So the value of F is 15. Okay. Now we are going to write the equivalent positional notation. What is the positional notation of first number, that is F? Right, that is 16 power 0. Next number 16 power 1. Next one is 16 power 2. So the first value is 16 power 0. The next value is 16 power 1 and the next one is 16 power 2. Now we are going to write the equivalent weight. What is the value of 16 power 0? So anything power 0 is 1. So you have to write the equivalent weight of 16 power 0, that is 1. 16 power 1 value is 16 and 16 square, 16 into 16 is 256. Now we are going to multiply the given number with its weight. So 1 into F, F means 15. Okay, 1 into 15 is 15. 16 into 5 is 80. Then 256 into 8 is 512. Now we are going to add all the values. 512 plus 80 plus 15. What is the value? Right, 607. Okay, the value is 607.
Now let us see
10.
hexadecimal to binary conversion. Already we have discussed binary to hexadecimal conversion. What we have done there? Just we have grouped the given binary numbers into 4 bits from right to left, and we have written the corresponding hexadecimal value using tabular column. Similarly, for each hexadecimal digit, we have to write the equivalent 4 bits binary value using tabular column. Just look at the tabular column. This is the hexadecimal numbers. It starts from 0 to 15. Okay, so 0 to 9 decimal numbers, then 8 to FR, 10 to 15 numbers. So see the right hand side, these are binary values which will be represented as 8421 code. That is 8 bit means 8081, then 4 bit means 4041, and it will be goes on. Then 2 bits mean 2021, then 1 bit mean 0101. Okay. Now let us move on to example. Convert A, B, C, B16 into equivalent binary number. Now we are going to write 4 bits binary equivalent for each hexadecimal digit for the given number using the tabular column. Okay. So the given numbers are 8, B, C. So what is the value of binary value of 8? Right, 1000. The binary value of B is 1011, and the binary value of C is 1100. Now we are going to make it as single group, that is 1000, 1011, 1100 base 2. So 8BC base 16, the binary value is 1000, 1011, 1100 base 2. So this is how you have to convert hexadecimal to binary. Students, the second part of this lesson ends here. I hope you understood these topics, right? And the assignment of this lesson is convert the given binary number into its equivalent decimal, octal and hexadecimal number. Submit your assignment on time. Thank you for watching this video. We will see you in the next video class. Assalamu alaikum.